SpaceX and its ambitious Starship lander are catching most of the criticism right now for the delays in NASA's Artemis program. But to be fair, SpaceX is making remarkable progress on one of the toughest engineering challenges ever attempted, and they seem to be pushing full throttle already. It's not as if every other part of the Artemis effort is running flawlessly while SpaceX alone is slowing things down. Still, it does raise the question. What else could SpaceX actually do to accelerate Starship's development? And if that's not possible, are there any alternate paths that could help them meet the deadline for such a demanding mission? If you haven't been following closely, NASA is now looking for fresh ideas for lunar landers that can help astronauts return to the moon. Progress on SpaceX's Starship mega rocket, which was originally chosen for the job, has been moving slower than expected. During an interview on Monday morning, U.S. Transportation Secretary and acting NASA Administrator Shawn Duffy announced that NASA will reopen the contract to develop the Human Landing System, or HLS, for the Artemis 3 mission, the one that's supposed to bring American astronauts back to the lunar surface for the first time since Apollo. The contract was first awarded to SpaceX, which Duffy described as an amazing company. However, he also expressed doubt that Starship's HLS variant would be ready on schedule, suggesting that Blue Origin or another contender might need to take over instead. The problem is, they're behind, Duffy said bluntly. They've pushed their timelines out, and we're in a race against China. The president and I want to get to the moon within this term. Unsurprisingly, Elon Musk didn't take the remarks lightly. He fired back on X, calling the interim NASA administrator Shawn dangerously stupid dummy. Setting politics aside, when you look at where the Starship program actually stands right now, it's easy to see why Duffy might be skeptical. Since its debut in 2023, SpaceX's enormous Starship rocket has flown 11 times, with mixed results. Some test flights ended in what SpaceX calls rapid unscheduled disassemblies, their signature phrase for explosions. But there have also been major victories, including the first successful landing of a Super Heavy booster back at Starbase, a critical milestone toward full reusability. While SpaceX has previously landed individual Starship prototypes, it still hasn't achieved a complete two-stage recovery yet. That's the next big step, proving both stages can return and be reused quickly, a cornerstone of SpaceX's vision for frequent, low-cost missions. During recent flights, Starship's upper stage has splashed down in the ocean after re-entry, helping engineers fine-tune its heat shield and descent systems. But the ultimate goal is to bring it home to Starbase. Caught mid-air by the Mechazilla tower arms, Elon Musk says the first on-site Starship landing could happen as soon as 2026. Starship still hasn't reached full orbital insertion, a crucial step for any future Moon or Mars missions. To make orbit, the upper stage must separate from the booster around 75 kilometers up and complete several orbital burns using its 6 Raptor engines. A true orbital flight could finally happen in 2026, followed by the toughest challenge yet: surviving re-entry and landing safely back at Starbase. Another key milestone will be in-orbit refueling, where one Starship transfers cryogenic methane and oxygen to another. That capability is vital for deep space missions like Artemis 3, and SpaceX plans to test it next year. To meet its ambitious Starship timeline, SpaceX has to clear a long list of engineering, operational, and regulatory hurdles. The bottom line, there's still plenty of work ahead. SpaceX remains, by far, the most capable space company in existence, but assembling all the pieces for a successful lunar landing will take time. SpaceX says it can meet a 2028 readiness date for carrying Artemis astronauts to the moon, which now aligns with NASA's updated Artemis 3 schedule. Still, this is spaceflight, how's that? And nothing in spaceflight is ever guaranteed. So again, the question stands, what more can SpaceX do? One major way SpaceX could speed things up is by cranking out reliable hardware even faster. To boost their launch cadence, they need a steady stream of new, super heavy boosters and Starships rolling off the line nonstop. That requires a highly efficient manufacturing system for engines and airframes that can keep up with growing demand. They're already moving quickly in that direction. The new Star Factory in Boca Chica is a game changer, built to slash construction times drastically. Inside the upgraded megabays, rotating work platforms and advanced welding robots keep production flowing around the clock. And they're not stopping there. A new gigabay is being built to speed things up even more. Actually, make that 2 gigabays, plus another Star Factory in Florida. Altogether, this nearly doubles their total production capacity. At the same time, SpaceX is developing 4 launch pads in parallel. Pad B at Boca Chica, one at LC-39A, and 2 more at SLC-37 in Florida. They're even assembling a horizontal transport barge to ferry Starship and super heavy stages between Texas and Florida before the new factories come online. Testing is another massive factor. The faster you can test, the faster you can improve. Expanding the McGregor engine facility would allow SpaceX to run more Raptor engines simultaneously, especially the upgraded Raptor 3 models. It's unclear how far along they are with that, but more test stands and trained staff could shave months off development. The Hawthorne facility might need to grow too. Raptor production isn't a bottleneck right now, but at the pace they're scaling, it could easily become one. Then there's the human side of things. SpaceX needs a massive number of skilled engineers, welders, and technicians. And those roles aren't easy to fill. It might make sense for SpaceX to launch its own training program, bringing in graduates and teaching them internally. They're already upgrading the Massey's test site after the Ship 36 incident, but adding another pad there could be a smart move. 2 static fire spots would mean one could be down for maintenance without halting the schedule. And imagine if they had a dedicated area for booster static fires, away from the main pad. That would free up the launch site for more frequent flights. Even the small logistics matter. A new private road connecting the build site and launch area would make life easier. Allowing rocket moves without closing public beach access and keeping traffic flowing smoothly during long rollouts. A nearby storage bay could also help, giving them space to stage large equipment or temporarily park a Starship awaiting its turn. And honestly, life at Starbase itself could use an upgrade. They've added apartments and a gym, but more creature comforts would go a long way. Maybe a cafeteria that feeds hundreds, a few cafes, or a shuttle running every 15 minutes between build and test sites. If more employees lived on site instead of commuting from Brownsville, operations would likely run smoother. On the administrative side, SpaceX also needs the paperwork to move as fast as their rockets. Securing and maintaining launch licenses is a major piece of the puzzle. Every new Starship variant requires FAA approval, and any holdup there can stall the entire program. A more predictable, stable regulatory process could make a huge difference in keeping launches flowing one after another. There's also the environmental angle. Starbase has been under tight scrutiny for debris, noise, and exhaust emissions. SpaceX must stay proactive, working closely with regulators to keep progress steady. The faster they resolve those issues, the less likely they'll face delays from environmental reviews. At the end of the day, it's hard to imagine SpaceX going any faster. They're already building new pads and new factories and testing almost nonstop. But knowing SpaceX, if there's a way to shave even a few days off the schedule, they'll find it. I still believe Starship will take humans to the moon, maybe even without NASA's backup plan. But with Shawn Duffy publicly emphasizing that China can't beat the US back to the moon, it makes sense for NASA to have a contingency in place. For now, NASA's approach isn't to immediately replace Starship, but to create a competition, a race between SpaceX and Blue Origin. Whoever gets their lunar lander ready first for Artemis 3 will likely get the mission. Blue Origin's lander design is quite different from Starship. It stands around 16 meters tall and is built to fit inside the 7-meter fairing of their New Glenn rocket, which, by the way, still hasn't flown. The lander can carry about 20 metric tons to the surface and be reused, or push up to 30 tons if it's a one-way trip. It runs on liquid hydrogen and oxygen, with its fuel tanks in the upper section and the crew cabin at the bottom. Blue Origin isn't going solo either. They're teaming up with major aerospace partners like Lockheed Martin, which is building an orbital refueling craft. Other companies are tackling systems like docking, navigation, and cargo handling. Right now, the human landing system has one main mission: to safely get astronauts to and from the lunar surface. The first few missions will focus solely on that. transportation, and temporary shelter for a short stay on the moon. It'll serve as both a workspace and protection from solar radiation while crews conduct science operations. Over time, the HLS will evolve into a larger role. NASA's already preparing for longer stays on the moon and early steps toward a permanent base. That means shipping tons of materials and equipment, habitats, mining tools, and resource processors that could help astronauts live off the land. But getting there isn't simple. Developing these landers means experimenting with a lot of brand new unproven technology, which guarantees delays and redesigns. According to the GAO, out of 11 key technologies needed for these projects, only 4 are considered mature. The real challenge comes when humans are finally on board. There won't be many chances for full-scale tests before that, so NASA has to strike a balance between speed and safety, a nearly impossible task. Elon Musk recently posted that building a permanent crewed lunar science base would be far more meaningful than simply repeating Apollo's triumphs. But that raises an important question. Why do we need a moon base now when we didn't 50 years ago? What's changed? And is it truly worth the cost given the ongoing delays within the Artemis program? Musk's tweet came right after reports surfaced that NASA might consider replacing Starship with Blue Origin's Blue Moon lander because of SpaceX's slow progress. But here's the thing. If the long-term goal is a sustainable moon base, Starship is still the best bet. Blue Origin's Blue Moon Mark 1 is mainly a test bed. It's not built to haul the massive cargo loads needed for real construction or long-term habitation. Starship, on the other hand, can deliver enormous payloads, enough for habitats, refining systems, and full-scale infrastructure. With that kind of capacity, we could start landing mining equipment and pilot plants to extract water, oxygen, and metals directly from lunar soil. If Starship works as intended, it could completely change how we use resources in space. SpaceX estimates that Starship cargo missions to the moon could start by 2028 at a cost of around $100,000 per kilogram, a tenth of what it used to be. That price drop is exactly what's needed to make a permanent base viable. And if this is really about beating China, then speed alone won't cut it. It's not just about who lands first. It's about who can build something that lasts. The dream of a moon base goes back more than a century and a half, from Jules Verne's From the Earth to the Moon to Wernher von Braun's 1950s space colony concepts. That vision fueled the Apollo missions, but after 1969, costs and shifting politics pushed lunar dreams aside. That changed in 2017 with Space Policy Directive 1, which set the stage for the Artemis program, a plan to return to the moon to stay, using commercial partners like SpaceX and Blue Origin. The logic is simple. The moon makes the perfect launch pad for deeper exploration. It takes 20 times less energy to launch from the moon than from Earth, thanks to its weaker gravity and lack of atmosphere. So, if we can refuel and stage missions there, Mars suddenly becomes a lot more reachable. But before that future happens, we have to solve the fundamentals: safe landings, power generation, radiation protection, and sustainable habitats. That means proper landing pads, dust control systems, and a carefully planned base layout. Think of it as a lunar city grid: zones for living, labs, energy, mining, and cargo operations. Every meter matters. Advances in technology and automation have finally made this vision feasible. Costs are a fraction of what they were in the Apollo era, and off-the-shelf components now replace custom hardware. With robotics, AI, and 3D printing, we can build faster and cheaper than ever. It won't be easy. In fact, it might be one of the hardest projects humanity has ever attempted, but it's possible. And with Starship leading the charge, the next great chapter of human exploration could begin not on Earth, but on the moon itself.